He's very unfortunate.
Yep. Okay, friends. So, on behalf of Center of Excellence in Advanced Manufacturing Technology at IIT Kharagpur, I'd like to welcome you all in this mega webinar series named the Saturday Manufacturing Talks. So, every Saturday at 8:30 p.m., we assemble, we listen to the eminent speakers from academics, from industry on different topics of the advanced manufacturing. Now, we are at the stage of Industry 4.0 or smart manufacturing. We have experienced the Industry 1.0 when the steam power has been used for the mechanization, electrical power has been used for assembly line in the Industry 2.0, and then we have seen also the usage of the robotics in Industry 3.0. Today is the era of Industry 4.0. We call it as a smart manufacturing. We'd like to see that how much smart our manufacturing is, what is the need of innovation in the smart manufacturing era, and how much we are equipped for this smart manufacturing to adopt, especially the country like India. We do have a large number of MSME sectors, large employments do come out of this MSME. So how much they have adopted the smart manufacturing the technology, because this is the disruptive digital tools which are used in the manufacturing sector to make the manufacturing process smart, to make the products flexible. Now, today for this wonderful topic, we are very much privileged to have Professor Amresh Chakravarty from Indian Institute of Science, Bangalore. So let me read out his, the bioscales. Professor Amresh Chakravarty is a senior professor and current chairman for Center for Product Design and Manufacturing of Indian Institute of Science, Bangalore. He is the topper in undergraduate from IIST Sripur, topper in MTech or Master of Engineering in the specialization of machine design of IISc Bangalore, and then PhD in engineering design from University of Cambridge in the UK. He led for 10 years the Design Synthesis Group at Center of Excellence Engineering Design Center at University of Cambridge. His interests are in synthesis, creativity, sustainability, and informatics. So you see all these points, all these areas are very much needed for modern manufacturing or the smart manufacturing concept. He has published 17 books, over 300 peer-reviewed articles, and has 11 patents. He co-authored DRM, which is a methodology used widely as framework for design and research. He has been associate editor and editor of several journals, including the Journal of Remanufacturing, and presently the editor-in-chief for AI EDAM. He founded Ideas Lab, which is the India's first design observatory. He is an honorary fellow of Institution of Engineering Designers. 16 of his papers won top paper awards in international conferences. He also heads the IISc TCS Innovation Lab, IISc Press, and the Springer International Book Series Design, Science and Innovation. He received Career 360 Faculty Research Award in the year 2018 for being the most outstanding researcher in decision sciences. He is also among the global top 1% of researchers in design, practice, and management. With this, I would like to, welcome Professor Amresh Chakravarty in today's webinar series. So now, Professor Chakravarty, it is your time.
Okay, thank you very much, Professor Surjokant Pal. I fondly remember the first time I met you. It was in Cambridge. You were a postdoc at that time, I think in Leeds. And then you visited us very kindly and spent some time with us. I very fondly remember. And look where you have gone now today. It's wonderful to see that. So first of all, I'm honored and privileged to be invited to this wonderful series. Thank you. And I would like to share my slide now. Just give me a second. Yeah, okay. I'm going to make it full screen, and do let me know if you're able to see that. Please
It is
let me know.
coming up at my end. Actually, that there is a network issue at my end.
Yeah.
Anand sir, can you confirm that it is visible?
It hasn't come yet. It is coming up, I think.
It has not yet come up. As well. Okay.
Okay, maybe we'll just wait for a moment then.
Yeah, there is a slight network problem today.
I think, sir, you can stop sharing and reshare.
Yeah.
If
Okay.
you want, I can stop sharing and then share again.
Shall I reshare? Stop share and reshare again?
I think that would be good. Yeah.
Okay,
Yeah.
I'll do that. Okay. Stop sharing. Okay. I think my internet seems to have dropped considerably. Just give me a second. I'm changing.
Sir, it is stopped. Sharing is stopped. You can share.
Okay, I've just resharing. Let me see. Are you able to hear me?
I can hear you, but I can't see your slide.
Okay. Let me just close this. That will close my slide. But it's for some.
You can do one thing. You can just switch off your video for the time being.
I'll do that.
And
I'm
then-
not able to operate it right now. It's just going round and round. Let
No
me.
issue. Please take your time. Absolutely no worries.
I'll just check my internet speed also. Are you able to?
Yeah, we can hear you distinctly. Absolutely fine.
Uh, right now, I'm not able to do anything. Let me just come back. Okay, please give me a second.
Yeah, sure. Please
It
take your
just keeps.
Ananta, can you please reconfirm whether Professor Chakravarti has rejoined?
Not yet, sir.
Can you hear me?
Yeah, you can hear.
Okay, let me try and share it again. Okay, are you able to see it again?
Yeah, now it has come. Yeah. You can go to the
Okay.
full screen mode and present.
Okay. Are you able to see full screen now? Can somebody confirm?
Yes, yes, sir.
Yeah.
Okay, I'll start. All right.
Yeah, sure. Please.
Okay. So once again, thank you. Sorry for the trouble. I think my internet speed is okay. Actually, it's about 60 megabyte per second right now. Okay. So I will actually go back a little bit and maybe start with around the time that Industrial Revolution, the first one, is starting. What was the situation at that time? So you're talking about India in the 1800s, right? It was at that point of time holding about 25% of the world's GDP, roughly the GDP of the entire Europe. It was one of the richest countries in the world, and it was also um, one of the leaders of manufacturing, along with the other leader being China. And it was very interesting scenario where UK was watching the leaders in steel manufacturing, and it happened to be India at that time, to figure out what is it that they did, India did, that UK did not. And what it found out was that the steel manufacturing in India was highly efficient and skilled. In fact, what is called Damascus sword used to be made from steel that was made in India. But this was not a scalable design. Okay, it could not go very highly, and in volume. So what UK did was, riding on the first industrial revolution, championed by many things, including the steam engine, as has been spoken about already. It made it scalable and became, over a period of time, the leader in manufacturing. Now, if we ride further up and look at Germany just after Second World War, it was in a similar situation. It was in complete tatters. Nobody would buy products made in Germany at that point. And it visited several countries, including the leading manufacturer of that time, and that was again UK, to find out what is it that Germany was not doing, that UK was doing, and what could they do to move up the value chain. And this is what they found. They found that there is a gap in translational research that they could fill out, which they did with the creation of Fraunhofer institutes that bridge the gap between academia and industry in translational research, which helped them become one of the leaders in manufacturing. Now, very interestingly, the history seems to have come round at the turn of this century, and UK again looked at the leaders of manufacturing, including Germany, to figure out what is it that they could do to move up the value chain. And what they found was that innovation was an element that seemed to have been missing in the translational research landscape, and they could actually invest in that, and they created what are called catapults. These are centers of excellence that can connect not only industry to academia, but also weave innovation, manufacturing innovation around that. So it is an interesting crossroad at which India is right now in the 21st century, where it is asking a similar question. What is it that we can do in order to move up the value chain? Now, we need to realize that manufacturing has undergone a number of substantial changes. Okay, first of all, the concept of manufacturing as materials processing has given way to an expanded view of manufacturing centric life cycle. A typical cost of an aircraft, well, 40 to 50% of the cost of an aircraft is not in materials processing, but in assembly of the aircraft. Okay, Rolls-Royce today talks about a product service system where they are selling not an engine, but power by the hour. In other words, they are taking responsibility for a wider part of the manufacturing centric life cycle, thereby ensuring that no matter what you are buying from us is a guarantee that you will continue to get power, whether our particular engine works or not. So it's an expanded view of manufacturing. Second is that the idea of research and technology leading the landscape is again expanded into not just research and technology. Of course, it's important, but innovation and entrepreneurship. How do we not only develop ideas, but also take them out to the society? The third is that the idea of an individual working in the corner of a laboratory making transformation has given way to the idea of an ecosystem, right? There's a bunch of people that are working together. They are taking advantage of the materials, the components, the technologies, the product, the platform, the supply chain, and the business in order to create an ecosystem within which this work can thrive. The fourth is that it has become apparent that there is an invisible king in this whole landscape, and that's design. And I'll come back more into the importance of design later. But please remember the 80-20, which says that in a typical product development process, the first 20% of the time is when we are taking decisions that are really significant in terms of the commitment of cost, but we are not actually spending that money. In other words, you can make very expensive decisions very cheaply, or the other way around. So it's also become apparent that as the technology moves forward, the role of training and education has become far more important than it has ever been before at all levels. The importance of infrastructure and support in developing this has become apparent, and it has become quite apparent that we need to not only have the short-term goals and support, but also the long-term goals and support. So it is interesting. I was visiting Hanover Fair a few years ago, and it was interesting not only what the wonderful machines that are on display at the various industrial booths were. Of course, they're exciting, but they're all yesterday's technology. What was interesting was to visit the university research booths, where you could see what the thoughts are for the technology that is going to come in about 10 years' time. So what is it that we can do? It seems that we have an opportunity with the increase in customization and the user preference, that we need to provide flexible scale manufacturing, okay, but which is affordable and high quality. It's not good enough to just give high scale manufacturing, but manufacturing that can be honed into the specific scale that is necessary at will, at a cost and a quality that appears to conflict with each other. And also, in order to support that, we also need to provide flexible scale training and rapid updation, which is also affordable and high quality. So how do we achieve that? And of course, this is where Industry 4.0 becomes important, and therefore we need to talk about Industry 4.0. I'll skip this slide because this is pretty much already spoken about by Professor Kapal. But let me just say that please remember, the first industrial revolution is about mechanization, okay, with power that is generated where it is spent. Second one is about electrification and organization of labor. So suddenly electrification gives us the possibility of not having to spend the power where it is generated. You can work at a distance. Tremendous flexibility. The third is that as about automation. How do you bring automation into individual elements within a factory or an organizational setup? The fourth industrial revolution is about autonomy. How can we look at the entire industrial system as a live entity in its own right together, and how it can operate largely in an autonomous manner without having to depend on one particular element. So I will skip what is Industry 4.0. I think you all know. It's a connected environment of data, people, processes, services, and systems and production assets, okay, that can help you generate, leverage, and utilize actionable information as a way of realizing a factory and new manufacturing ecosystem. So there are 4 elements to remember about a smart system. One is that the objects or components are self-aware, whether it's people, product, process, tools, environment, they're all data is being collected about them. Second is about they're connected to each other. So there is a communication network that is underlying that. Third is that this data is continuously stored in real time. And fourth is that there are autonomous analytics that is being done on this data to make decisions and then bring that decision back into the system. So these are the 4 essential elements of Industry 4.0. And there are also a number of new design manufacturing and communication technologies, including additive manufacturing, collaborative robots, augmented reality, and so on. So these are seen as some of the key benefits: high efficiency, high agility, large amount of innovation, customer experience, costs reduction, and revenues. Also, there are challenges. Cyber security is a major concern. Skilling is a major concern, major area. Of course, change is always seen as with suspicion, sometimes with good reasons, and also issues related to IT, reliability, and stability. These are seen as the 9 elements of Industry 4.0. I will not again dwell on them because I think most of you are already aware of them. Autonomous robots, simulation, big data analytics, augmented reality, additive manufacturing, the cloud, cybersecurity, industrial Internet of Things, and integration at the systemic level, both horizontal and vertical, across the functional elements as well as across the sensors, the data layer, the communication layer, and the analytics layer. So the big sort of dream is the following, that if all of these are done and you are looking at kind of a cartoon of all those technological elements, that they will variously influence four elements, four functions. One is collection of data, exchange of data, storage of data, analytics of data. That will influence the quality, the productivity, safety, the so-called key performance indicators, which in turn will improve the value in product production, supply chain, and business, leading to greater competitiveness. That's the dream, right? But let's look at the reality. Okay, and I'm particularly going to talk about the micro, small, medium enterprises in India and its relationship to Industry 4.0. Now, I think we all know that the MSMEs are the backbone of jobs in any country, whether we are in India or in Korea or Germany. And in India, it turns out that there are about 60 million organizations. They carry a very substantial percentage of the jobs. And 33% of the manufacturing output, 45% of exports. These figures are not very dissimilar to those in Germany or Korea. They are Mittelstands and so on. What is very interesting is the difference. And that is that while the Korea in Germany, the small and medium enterprises hold about 80% of their GDP. In India, it's about 20%. So clearly there is a disconnect in terms of where these MSMEs kind of lag behind. And it turns out that it is strongly related to the fact that there are about 90% of these are micro organizations. So there are less than 9 employees. So they're very small, well, micro. And when they are very small, what it implies is that they are unable to invest into upskilling, technology, processes, and innovation. There is a study in OECD countries that shows that if you are a medium employees company, about 50 to 50 employees, you are about 80 to 100% more productive than if you're a micro enterprise. So the fact that 90% of those organizations are in that space actually holds us back in terms of moving up a value chain. So how do we improve this? They obviously see smart manufacturing are highly capital intensive, and they do not see clear benefits of their investment, and they also perceive a loss of jobs. This is clearly, there's a low uptake of MSMEs. How do you improve this? And this is where innovation comes in, right? And let's look at the story of innovation, and by looking at the Global Innovation Index graph. Okay, so Global Innovation Index is a study that is carried out by an international body in order to find out how innovative the various countries are. And the slide that I'm showing, let me just take a pointer. Okay, so you see, what you see here is that the x-axis is the amount of input investment you make to innovation, and y-axis is in some quantity the innovation output. Okay, and largely if you see each dot is one country. So you can run some kind of regression and find some straight line. What that says is that by and large, if you invest more in innovation, you're going to get more output of innovation. But that's only part of the story. What is quite interesting are these broad bands here, like the vertical band here or the horizontal band here. What it means, the horizontal band means that even though you invest very different amounts, the countries can get very, very similar innovation output. And what the vertical line or band shows is that for the same investment, right, you can have very different innovation output. So clearly, just investing is not good enough. There is something more than just investing. The second thing is that there is a correlation between innovation and improvement in manufacturing. So the two are actually quite intimately related to each other. And that's not so difficult to understand. Obviously, if there is greater innovation, there is greater investment in making those innovations possible, which means there is greater amount of manufacturing. The last one is quite interesting, that innovation correlates to growth. Once again, if you look at the slide at the bottom, I don't expect you to read it, but let me just explain that what it shows is that the way in which innovation growth moves, okay, is similar to the way in which R&D growth moves. In other words, when you have greater innovation in a country, there is also greater economic growth. Now, that's good news. But once again, please remember that the same investment can lead to very different innovation outputs. And this is where design comes in. Okay, design is essential for innovation. Design is what ensures that the right problem is solved right. Okay, and therefore it needs low investment and ensures better decisions. We'll come back to the story of design. I'll just show you some innovations. Well, let's spend a little bit of time on innovation. Okay, what is innovation? One of innovation is finding opportunities and problems in the society and going around and creating solutions or means of fulfillment and bringing that down to society. So it starts with society, it ends with society. It doesn't quite end. It starts again for another cycle across that. Now, if you go further down, just divide that into multiple points. This is what you see. And you can, of course, divide it in 7 or 8 or 9 boxes. But based on my experience, these are the 6 elements that are quite important as milestones in the journey of an opportunity to become a solution or a business, eventually leading to the solution being in the society. One is the opportunity, second is idea, third is product, fourth is production, fifth is supply chain, sixth is business, and water. So basically, you can ask the question, is the opportunity the right opportunity? Is the idea the right way of catering to the opportunity? Is this the right way of embodying that idea? Is this the right product? Is this the right way of making this product? Is this the right supply chain in order to make the life cycle of that product possible? And is this the most appropriate business model? And of course, one can go wrong in any of these steps. So making some back of the envelope calculation, if you take a chance of success of 50% in each stage, your overall chance of success is pretty low. In order to get a decent level of success, you need to have a pretty high chance of success in each of these so-called valleys of death. Right? And therefore, once again, you can see why it's not so surprising that only about 4% of innovations in India, and the global average is not very different, succeed. So where is this opportunity for India's manufacturing experience? Okay, we need to remember, as I see, 3 issues. One is that the current technology for Industry 4.0 is not affordable for MSMEs. Studies show that if you make something affordable by about half, so if some cost of something goes down by half, the market size goes up by about 4 times. So you get a much greater multiplier. So how do you make technology for Industry 4.0 more affordable? Okay. Second is that how greater investment to innovation leads to greater innovation. But as we said, same input can produce very different output. So how do we make that different? And third is that unsystematic innovation has a low success rate. How do you make innovation more efficient? And the proposal is the following, that we need to develop Industry 4.0 technologies that are not just affordable, but advanced affordable. Okay, that sounds like a contradiction in terms, but I will show you some examples where this is possible. When you want to make something really affordable, it has to be advanced, because you have no other way of simply making cosmetic changes to make them so very affordable. We talk about 10x technologies. Can I make something 10 times cheaper by simply optimizing? No, we cannot. So you need to really go out of the box, and you have to develop something quite different. And this is why we need to make innovation more efficient and for the entire innovation for the life cycle. And this is what the proposal is, that we need to have design-led data-driven innovation. How do we create? And third point is that how do we make Industry 4.0 more inclusive by creating smart, innovative MSMEs? So 3 levels. One is, can we create new technologies that can help? Second is that, can you create innovations that are design-led and data-driven? And third is that, how can we make MSMEs themselves more innovative? So smart design, smart products, smart manufacturing systems, services, and businesses. Okay, so going back to the story once again, the original story that I had started with, that India to UK and back to India, in some sense what the first industrial revolution did was it focused on production. How do you make production more scalable? By using machine power or by rationalizing labor. In the second industrial revolution, it still focused on production, but it connected it to the product or ideas that came from academia. So essentially connecting idea to production. In the third level, at the story of UK, they were expanding that to support innovation in manufacturing. And I think time has come for us to look at how can we go beyond that and support design-led, data-driven innovation for the entire life cycle. Okay, and therefore design therefore plays a significant role, and therefore you probably are going to ask the question, what is design? Well, design starts with something that you do not like. If somebody likes everything, then he's not a designer. So you start with an undesired situation. For example, village folks in rural India and many other countries have to walk a large distance to the water source. Now you can say this is an undesired situation because that's a long distance away. One has to carry the materials and bring it back. There are issues of safety. Roads are not particularly good. Washing is effort and time consuming, probably pollutes the water source and so on. So depending on what you take as major issues, you probably start looking for what is more desired. Shall we bring the water closer to the home? Shall we help them carry clothes? What shall we do? Shall we make the road safer, cheaper, easier, and so on? Okay, and that makes your goal. And then once you created your goal, you start planning how to change the undesired situation to a more desired situation. And design, and this is a rural washing machine, by the way. One possible way of supporting this, not necessarily the best way, just to give an example. Okay, so design is plan. Okay, it's a plan for change, and it's plan for whatever the change is. Okay, that makes it completely agnostic to the technology. And designing, the process of design, is how a design is developed. It's not just the plan, but also the goal. Goal is also something. So you basically say to your question paper, and you also answer the question paper. Nice situation, isn't it? So that's what designing is. And depending on who you are, if you're a technical systems designer, you're probably designing a power plant or planning for a power plant. If you're an educational systems designer like Montessori, Maria Montessori, maybe you're developing a Montessori method. Or if you're an aesthetic designer, maybe you're designing a logo. Or if you are a legal systems designer, okay, like a policy maker, you're developing laws and so on. And this is the holistic view that one has to bring in when one is trying to train people into innovation. What is it that we need to learn? We need to learn to have a mindset for innovation. Innovation in product. We looked at the first 2-3 stages, like what is the opportunity, what is the idea, what is the product. All of them is part of product innovation. We also can innovate in the production, services, and business. All of them will require a mindset for innovation. But just having a mindset for innovation, such as design thinking, is not alone enough, right? An aircraft with 20,000 parts is not going to be made by just having a mindset. You need to have a structured process. So you need to have a structured process where all of these efforts can be orchestrated together, okay, to create something that works reliably, and works every time, right? You also need to have the science and technology building blocks. And I'm not only talking about science and technology of objects, right? I'm talking about science and technology behind what people find interesting, usability, building blocks, aesthetic building blocks, and so on. And of course, the tools and methods that make all of these possible faster, cheaper, and easier. Somebody has to remind me of the time. How am I doing with the time? How many minutes left?
It's fine. It's fine. Please go ahead. Yeah.
Okay.
So only, the 5 minutes past 9. So you have got enough time to go.
Okay. Okay. Thank you. So here are some examples of design, and this is Anup Chandar and Govind Sharma, who designed a diverter flip-flop, right? It's a flip-flop. If you use that flip-flop and walk on muddy water, it's not going to splash water back to your feet. And this is for this design, these two students, ex-students of our department, who got the Red Dot Award, which is like the Oscar of Design Awards, from competition from 58 countries in the world. This is Mona Sharma, design head of a company based in Bangalore, who have developed a product called Bempu. Bempu is a wristband, okay, which one puts on babies in order to sense their temperature for hypothermia, too low a temperature, which has been a major cause of death of babies around the world. It's a relatively inexpensive solution which has sent, just in 2017, 10,000 newborns around the world, which is why Time magazine picked this up as one of the top 25 inventions of the world. This is the first racing bike from TVS. TVS is a company in India, for those who are from outside India, which makes racing bikes for BMW. This is the first racing bike that they created on their own, and the entire industrial design was done by Arun Francis. What I'm trying to say is that when we talk about technology, we don't only talk about technology of engineering. We talk about technology of usability, technology of aesthetics, technology. All of them have to come together to do it. This is one example of that. This is a successful agri startup by Nitin Gupta and Nikhil Meshram, two master students, who created a product for supporting cotton harvesting productivity. And then they went on to create a company called Sickle Innovations, and you can Google that. It has been relatively recently picked up as all kinds of awards, including the Ministry of Agriculture's most innovative agri startup in India. And last example is Purak. It's a prosthetic arm designed by the two students that you see here, Nilesh and Vinay, who basically created this first prototype, is what you're seeing on the top on the right side, where they said, well, we would like to use a single actuator in order to have an under-actuated arm that uses the muscle signals that comes when somebody, an amputee, tries to grab something and uses that as a way of signal in order to wrap around an arbitrarily shaped object, this prosthetic arm. So basically a single actuator, and that's where cost became substantially less. And then they got some more funding from Wellcome Trust, and also Oxford wanted to collaborate, and so that they could jointly launch this in both the countries. When the Prime Minister of Britain there at that time, Theresa May, visited India, she said this is the most shining example of collaboration between India and the UK. Now, they have a company now called Grass Bionics that's selling this product. We were asked that we should not sell it so cheap that people will think that this prosthetic arm doesn't work. And that's what I meant by advanced affordable product. How can you make something by going out of the box so that it's so seriously affordable that it can really make a difference in lives of many people? Okay. So this is just a very quick introduction to my department, where all of these were primarily trained at Center for Product Design and Manufacturing. It's the design and manufacturing phase of IISc. It's among the top 3 design schools in India. Our interest is, of course, pursue excellence in design and manufacturing to support development of systemically complex, technologically intensive, and socially impactful solutions by bringing together the functional, the aesthetic, the usable, and the sustainable. And we have a very strong focus on hardware-centric prototypes, an area that India has been traditionally particularly bad at. We have an MTech in smart manufacturing, an MDes in product design and engineering, and research in both these areas. Smart Factory is an initiative that we took upon ourselves in order to create an ecosystem around which all of these manufacturing innovations can take place. Smart Factory is a common engineering facility center. It's funded by the Department of Heavy Industries. In fact, well before the Smart Factory initiative, we started India's first R&D platform in smart manufacturing with a seed funding from the Boeing company. And then we have been lucky to have this funding from the Department of Heavy Industries. It's a private-public partnership, so about 80% of the money comes from the government, in this case, Ministry of Industries, and about 20% comes from our partners, Ashok Leyland, Faurecia, Yaskawa, Tata Consultancy Services, and Toyota. And the idea is that we create a platform, okay, which is supported by 11 departments at IISc. The key question that you ask is the following, that remember the MSMEs, right? About 90% of our country's manufacturing is in micro or small enterprises, and they are largely human intensive, labor intensive factories. So how do we use smart elements to empower human labor to enable greater productivity and quality, just as the other view of Industry 4.0, where one has to usher in productivity through automation only. So we are actually creating not one but two platforms side by side, one with advanced features that are available by way of automation, and the other is a frugal one that is suited for immediate adoption by the MSMEs of India. So what I'm showing you are cartoons of a typical factory, and let me just run you through. The reds are the incoming and the outgoing storage and inspection. The blues are the materials processing units, machines if you wish, and the yellows and saffrons are the movement of materials. Okay, that's essentially what a factory is, right? So you have the same thing on the top and the bottom. The difference is the following, that the top one is an automation intensive setup where your machines are data intensive, such as a 3D printer or a laser router and so on, or a CNC machine. And the bottom one is all manual legacy machines that are typical in a micro or medium small enterprise. The operations are carried out by humans or manual cranes, as opposed to what is at the top. It's the robots, the collaborative robots, or the automated guided vehicles, in addition to humans who are responsible for the movement. So the difference is that this is largely a manual kind of factory, and this is largely an automation intensive factory. The difference is that both of them are connected. These blue lines are basically connectedness, one of the elements of Industry 4.0. Second is that each of them we have put a data layer so that the legacy machines are also providing the are people able to see my slide? Hello?
Yes.
Okay. Sorry, I saw one message saying no video at all or something. Okay, so what you see are these light blue lines. That is basically connectivity. Each of them have been put a data layer so that you can draw information from each of these machines. And there are tags that are attached to the humans, so you can basically connect data about them as well. And all of them, of course, have this green block at the top, and that's the data analytics station. So the idea is that if you bring in the 4 elements of smart into factories, no matter whether it's a labor intensive or automation intensive factory, what difference does it show? And that's basically what we have been creating. And please remember that we can take portions of one factory and connect to portions of the other, so you can create hybrid factories as well. So essentially it becomes a test rig, a factory test rig, around which you can try out innovations and see the difference this makes on the KPIs, the key performance indicators such as quality, safety, productivity, or resource utilization. And this is just a few screenshots from that. So what you see up there on the screen is a digital twin of the factory. And this is just a head-mounted display for getting a 3D virtual reality-based view of the factory. And this is automated guided vehicles, which is carrying a collaborative robot in order to carry out some tasks. So some of the projects that we are running, real-time assessment of worker safety, affordable asset tracking, automated knowledge acquisition for use in manufacturing, making legacy machines smart, making MSME certification worthy. That's a major problem. How do you make MSMEs more certification worthy so that they become more acceptable as a reliable supplier to the OEMs? Using smart for sustainable manufacturing, can we do real-time assessment of environmental impact of a factory and find out hotspots and take actions to change that? Developing multimodal robots which can operate, and I'm going to talk a little bit about that. So here are some examples, right? This is work. This activity was with a micro manufacturing unit just at the outskirts of Bangalore. They are shoe makers, shoe manufacturers, and they had a problem with inspection of the incoming materials because defective materials would creep in and reduce productivity and rework. Okay, both costs. And so we created an activity with which we could get manual inspection can be supported for better things like that. This is a smart solution for essentially figuring out the waste, the amount of waste that is getting generated around a factory, which you can then track and see where the waste is getting too much and so on. This is another such inspection solution where again it's a advanced affordable solution by using relatively cheap cameras to take photographs and using some sophisticated algorithms for image processing to find defects and ensure that incoming inspection becomes more reliable. This is a multimodal robot where the interaction with the human happens through not the usual typing, but through other modes such as eye gaze or gestures. And so the idea is that in future robots are going to be more like humans, and they will operate by talking to each other rather than, or gesturing to each other rather than through traditional interfaces. Okay, this is a hybrid machines where robotics and 3D printing come together both for metal and polymer in order to create embedded products, print embedded products in the same machine. So this is just a very quick overview of the IISc Advanced Manufacturing Program that then grew around the smart factory. We started the MTech and the PhD program about 3 years ago, and supported R&D projects with these companies such as Yaskawa, that's a robotics company, Faurecia, that's an automobile manufacturer, and so on. And training around the industry. Just about, we have been training people like HAL, Ashok Leyland, and so on, but just about to start a program in order to train the industry professionals online on Industry 4.0. Support innovation projects with MSCs. I've shown you glimpses of some, and awareness program on Industry 4.0 for PSUs and so on. These are some of the research areas: additive, digital manufacturing, sustainable manufacturing, robotics, asset localization, design thinking, and so on. The MTech program just want to create future leaders in manufacturing, and therefore the course have to be multidisciplinary along with advanced materials manufacturing process kind of courses that's typical in a manufacturing course. We also want to have digital design, digital manufacturing, and human-computer interaction, system sensors and AI, and supply chain and entrepreneurship to get a 360-degree view, and your feet, one on smart and one on manufacturing, to come together through hands-on skills training and industry lab partnerships and research development projects. So this is the team. This is a much larger team, of people from, as I said, 11 departments. I'm not going to name all of them, but my thanks to all of them. And just before I finish, I just want to, of course, invite you to Industry 4.0 and Advanced Manufacturing International Conference that we started about 2 years ago. Professor Pal is is one of our co-chairs, and we are having that conference sometime in January, 10 to 11th of January next. Sorry, the number is wrong actually. It's 10 to 11 January 2022. So that's something that I would like to invite all of you to. So with that, I just want you to remember, if you remember only one thing about Industry 4.0, it's about connected intelligence, connecting people, product, process, tools, and environment. And to carry that out, design innovation is the key. Thank you for listening and your attention. Thank you.
Yeah, thank you so much, Professor Chakraborty. You have given us a very nice introduction about the Industry 4.0. It's all key elements and the challenges of Industry 4.0 and all. You also talked about what is the India's need for at this 21st century done the smart manufacturing in this field of the smart manufacturing and all. Just one question is coming up in my mind before I proceed to the audience. As you have rightly stressed upon the need of the industry 4.0 implementation in case of the MSME sector, because the MSME sector is largely, the labor intensive. So how much equipped they are, because you have also formed an ecosystem of, the public private industries at your CPDM or the smart manufacturing center. So how much they are equipped at this moment to adopt the digital tools of the industry 4.0. This is number one. And the number two question is that, if we adopt the industry 4.0 in, the true sense, implementing all the digital tools, what will be the scenario for the labor? So how much reduction of labor will be there? If not, how they can be equipped with the enriching their knowledge in the STEM, science, technology, and engineering environments. These two questions I'd like to.
Okay, sure. Thank you, Professor Pal. I think they are both very relevant questions. The first question is how equipped are our MSMEs to adopt Industry 4.0. Second is that what happens to the labor force as Industry 4.0 gets more adopted. Okay, so I kind of partly tried to answer the question of how equipped industry MSMEs are. I think the major dilemma for the MSMEs is the following: that the technology for Industry 4.0 is not particularly affordable for the MSMEs, and right now they do not see the benefit of adopting it. Partly because, as I said, most of them work with hand to mouth, and they don't have the outreach in order to adopt it. So the answer is, except for the more sort of upscale and medium enterprises, most of them are not equipped. So that's where it creates an opportunity for us to create more affordable Industry 4.0 technologies that they can adopt. But the question then still remains that what is the benefit of adopting it? And I think this requires two visions. Okay, one is that in some sense, if they do not adopt, okay, they are eventually going to not remain competitive. So they will have to adopt, but we should make it easier for them to adopt by creating more affordable technologies for them. Now, coming to the second question about labor, okay, whenever there is a disruptive innovation, the market landscape is going to change. Imagine the scenario where everybody was riding on horses, okay, and then somebody came up with the idea that we have to have a car. Now that's a disruptive innovation. Clearly, the jobs that were held those days around the horse carriage technology have been largely hampered by that. But what has been shown in retrospect is that such disruptions have had local effects in terms of the market, the established market, but then new markets got created because new jobs got created. And this has been largely the story of the industrial revolutions. On the whole, they have made our lives much better. The way people lived, the large body of people lived around the world at the 1800s was much worse than it is now. And the same thing is going to happen, I believe, in Industry 4.0. Some of the traditional jobs are going to go away, but new jobs are going to come. But that requires us to remain ready for that, and that requires upskilling and training in these areas. And that's the reason why I had mentioned at one of the earliest slides that we need to have flexible scale training and adaptation at all levels. And that's the only way in which you can upskill them so that they can take up jobs that are going to come in now and in the next decade or so.
Yeah, I also feel the same thing, because through automation, through robotizations and all, a lot of jobs are going to get created. But at the same time, if that level, one has to understand that complete, the understanding about the knowledge of STEM. You're right to point out that. There are some questions in the chat box. Let me read one by one. Can you also see the questions at your end?
I'm not able to. How do I make this screen bigger? Right now the screen looks very small.
Yeah, you please unshare yourself first and then you
Oh,
can.
unshare. How do I unshare?
Yeah. I mean, Ananta, can
Okay,
you-
okay. I've managed to do that. No problem. Please go ahead. Okay, I can see some questions.
Yeah,
Okay,
so
let me open the chat.
yeah.
Okay. Yeah. So Farooq Mistry, I think he just said thank you. Okay, maybe you can read out the question. I'll answer.
Okay, so Professor Mistry has told that the design engineering in the age of Industry 4.0. If you want a copy of that paper, please email me. Okay, so that means there are some papers on the design of. See, then let me read. Professor Chakravarti, it has been a great session, very informative and very informative. Professor Dr. Pranav Kedan has his appreciation. Professor Farooq Mistry has told thanks, always interesting. It's another appreciation. The key message is that we need to augment Industry 4.0, make in India, to design in India. So this will contribute Atmanirbhar Bharat. So that is another statement by Dr. Farooq Mistry. Dr. Praveer Sarkar has mentioned that thank you, Professor Chakravarti, for your wonderful presentation. So I don't see any questions as of now. Yeah, it's getting.
Okay, so I see one question. It says, "What is chasm?"
Yeah,
Okay.
that's
So
by others. Yeah.
yeah, I think that it means gap. Okay, it means a very deep gap. That's what's called a chasm. Yes.
So value of A.
Yes. 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 Exactly.
Yeah. So any other questions? If anyone is having, just please type quickly in the chat box. Professor Sumir Majumdar has written that excellent presentation. One simple question is that is there any participation by the aerospace industries in India? That's the question.
Yes. Yeah. Absolutely. Yes. So okay. So let me broaden the question a little bit. Let me first answer. Is there any partition with aerospace industry in general? The answer is an emphatic yes, because they see tremendous opportunity there. I got exposed to the early versions of Industry 4.0 through seminars that were organized at the Boeing company. It used to be called network enabled manufacturing those days. And that's how we sort of sat together and created the concept of an Industry 4.0 R&D platform way back in 2014 when it started. But in the Indian context, HAL, for example, Hindustan Aeronautics Limited, it had come to us. We had a plan for creating a training program for them. So they have been one of the early adapters in terms of training into Industry 4.0. There are several companies right now, some from ISRO, some from HL, who are doing their PhD in Industry 4.0 in our department. So definitely there is a strong interest in Industry 4.0 by the aerospace industry in India. Yes.
So is there a scope of research collaboration with CPDM? I see.
Of course.
Yeah.
Nothing big can be done alone. The only collaboration can help us get anywhere. So yes, the answer is again an emphatic yes.
Yeah, Professor Chakravarti has rightly mentioned at the beginning that's the connectedness. So a lot of things, a lot of modules are there, a lot of disciplines are there. So manufacturing is very much transdisciplinary these days. So
Exactly.
So I mean, before the others, write some question in the chat box. So since you're interacting with the MSME sector, so that which are based, in Karnataka and nearby Bangalore and all. So how do you find their interest in adopting the Industry 4.0?
Yeah, so Surjo, there are different kinds of MSMEs. Okay, I'll give you three examples. Okay, one, see, normally most MSMEs are not ready to, or many industries are not able to, okay, spend money on this. Okay, they are not. They will spend money only on that can give them immediate return. Okay, so so with some of those people, we are actually producing solution, implementing in their, for example, that inspection solution that I showed you, that we have implemented that in a micro manufacturing unit. And what we are going to show them is that it will take about a year before it breaks even. Not that they have paid for it. We'll simply show how much savings it makes in a year. And we are confident, because we have done the calculation, that within a year or less, it will already break even for a 10x solution. This inspection solution costs about 12 lakhs in market. We have created a solution that costs 80,000 rupees. Even that for a micro manufacturing unit, it has to come from the savings, and that's something that will take about a year for them to accrue. But the point is that it is possible to do it. The second example is MSMEs are these kinds where they are ready to take a solution. Okay, they understand the importance, but they are not yet ready to pay money for it. Okay, this is where the government can come in and hold hands with us and say, okay, fine, money comes from us, you give us the problem, let's solve it together and let it go and make a difference. Once it makes a difference, they see the value, maybe they will be much better off. The third kind is that they already know the value, they are ready to invest as well. So I have seen these all three different kinds of MSMEs. It depends on who you engage with.
Yeah. It's true because some of the cases, the Center of Excellence in our Advanced Manufacturing Technology, Kharagpur, we also came up with some, the AI-based solution for the product quality inspection in the real time. Got the very good success on that. But when you approach the industry, so they initially take the backseat, like is it going to basically trash upon our jobs scenario, because most of the MSMEs, most of the cases, MSMEs are dependent on the local people. So they
Yes,
also
yes.
get a little bit of scare. So one question is that, can you please share the contact mobile number? So Mr. Day, you will get it from the all contact number of Professor Amrit Chakraborty. You will get it from the university ISU website. You can write him an email. And then
Yeah. I would prefer an email ID,
Yeah.
email first, and then we can maybe interact and find out where the need is. Okay. How does a developing country like Bangladesh improve its innovation through investment? Well, I think there is greater design thinking teaching that should happen in the engineering colleges and institutions. I think that's the very low hanging fruit for innovation. We need to lace our technology education with design education. That would be one low investment opportunity for improving innovation.
Another point I feel that as an academic institute, we will have a strong role to play in giving training to the industry people. So that's that very much required these days. So that they can quickly understand the importance of these modern concepts and they can implement in the scenario.
Absolutely.
Professor Subir Majumdar has written that when an MSME requires upfront seed funding of rupees 1 to 2 lakhs only, can you work with the banks to finance with soft loans for up to 3 years, since the bank even is about 1 year? Is the break even is of 1 year?
Yeah, so I think governments also have a number of schemes, such as there are MSME centers of excellence, which are meant to fund a substantial proportion of the money. But what the MSME government wishes to see is that the MSME actually has a genuine interest in the innovation. It should see what happens when all the money is spent by somebody else is that many times the interest is not genuine. So I think that buy-in has to be there from the MSMEs. So it's not the government cannot spend. See, there are many 80-20, just like the smart factory initiative I spoke about. It's a 80-21, right? It's a 25 crore funding, of which about 5 crore has to come in cash from industry. Why is that? Can't the government give 5 crore more? Yes, of course it can. But what the government wants to see is that the industry sees benefit in having this setup and the activities around it. And one way to measure that is that you actually they are spending money. So it is the buy-in that they would like to see from the MSMEs. It's not so much that they cannot fund.
Yeah, it's absolutely true. You have rightly pointed out. I also, feel the same way. Like the 80-20 relation in funding, 80% from the government and 20% from the industries. In our case, we got a huge amount, like 65 crores from. Out of that, 80% came from the Department of Heavy Industries and 20% from the various industries. So there also I find that the huge interest, from the industry. We have the presence of Tata Group, 4 Tata companies are there. So there is a very good interaction. So I mean, the ecosystem is really good developed. One question is from Dev1G. That do you have any workshops in structured innovation for MSMEs? Dr. Dev,
Yeah.
Yeah.
Yeah, the answer is yes, we do. We do hold workshops in design thinking and structured innovation. Yes, we have a innovation window at IISc. It's called Society for Innovation and Development. So under the ambit of that, we actually hold workshops for them. Yes. Not only we do hold up workshops, we also have a program where the advanced thinking MSMEs can compete, and they will be selected, and a select group will be undergoing a 6 months training in developing a solution to one of their problems, where they will be handheld by the design students of our department. And this is part of a, this is already running for 3 years now, and it has produced some really interesting innovations that has immediately got into and be implemented. And we have a bunch of people who are those MSMEs who have become more innovative as a result. So it is training of MSMEs to become more innovative.
Absolutely. I think we have read all the questions. If any question is left, please do type again or raise your hand. Yes, I can see that. Yeah, all questions are read and answered by Professor Chakraborty. So thank you, Professor Chakraborty. It is we are really privileged that you took out time out of your busy schedule and all, and today you are present with us. Thank you so much for your wonderful insight in the field of this Industry 4.0 and what we should do while we stand today. You have rightly pointed out the need of innovation, need of design, and all how design plays an important role in fulfilling or making the industry the smart. With this, I'd like to finish today's session, and now I request Mr. Ananta, doctoral scholar, to let us know that who will be the speakers for the next weeks. Ananta, are you there?
Yes, it is here, sir.
Yeah, so the next week, that is August 21st, we do have the Derek Seglarek from the Warwick Manufacturing Group in the University of Warwick. Professor Seglarek will be talking about the sensing systems and networks in the field of manufacturing. Then August 28th, Professor Adrian Gilrich will be from University of Waterloo. Professor Gilrich will be talking about the high productivity welding process for pipeline construction. With these two, the webinars will be finishing the month of August, and then we are also scheduled for the month of all the videos are uploaded in a Google Drive, so you can scan these the QR code and get to see if you have already missed something. Thank you so much for your presence, and I look forward to see you all again the next week, 8:30 Indian time. Thank you so much.
Thank you. Thank you. Bye-bye.
Thank you. Bye-bye.